Okay, now we're talking about DC and also a few things about AC. Okay, first thing you can see this will be the time domain. What that mean? That means they vary with the time. Okay, this is the time domain. This is the DC direct current, and that will be AC alternate current. Now, on the DC direct current, you can see your car battery. That's a direct current 12 volt. Okay. And this is the battery, positive and a negative. So basically, they display on the time domain. You see this direct voltage will be just a straight line. Okay. Maybe 12 volt. Now, another one. This is the sine wave. That will be a AC signal, where you can see the AC signal that coming out from your home outlet. Okay, 110 volt AC. They just a sine wave. So what I want you to understand when you see the signal display for direct current, okay, they look like just a straight line. However, if the AC, they will be a sine wave. Okay. Now, DC, we don't have anything to talk, but the AC, that's a problem. So AC signal, they say signal name. That we call a sine wave. The time domain, amplitude vary with the time. So the voltage from 0 here go to the top. That's what they call the peak. Or from a 0 go to the bottom. That will be definition, the peak. Okay. And the voltage from the top to the bottom. They call a V peak to peak. So in here, you can see V peak 5 volt. V peak to peak, you know that 2 times of V peak, they will be 10 volt. Okay. And the time from 0 here up to that one. That means complete one sine wave. Okay. They say this is the period. Okay. One cycle. And period, they call it T. Period. Complete one cycle. You cannot using the oscilloscope, this display on the oscilloscope to measure the frequency. Okay. So you have to do a calculation for the frequency. F is frequency, and this is the formula. F equal 1 over T. If you get the period T, you can calculate the frequency, okay? Or if you get the frequency, you can calculate the period. And in this formula, T have to be in second, okay? And F have to be in hertz. That unit basic of frequency, okay? So, what I mean a cycle, okay? One complete occurrence of a repeating wave periodic signal such as one positive and one negative alternation of a sine wave. That's what they call a cycle. Frequency, the number of cycles of a signal that occur in 1 second, and the period, the time distance between two similar points on a periodic wave. That's just a very, very basic. Okay? Only thing I make sure you just go to the basic in the handout over and over. You don't have to read any different textbook. Okay? That handout will be given to you in the basic for technician. Okay? The next one, common power of 10. Okay? So you can say 10 power of 6 or 10 minus 6. You can say how many number? Power of 3, 1,000, 100,000, power of 5, 10,000, power of 4, power of 3, power of 2, power of 1, power of 0. Okay? To handle with the larger number in electronic system, use power of 10 notation. Okay? The number 10 equal a base 10, and its power equal a exponent. Like you get 247,000. You can write different way using power of 10. 2.47 times 10 power of 5. That means from here you get 1, 2, 3, 4, 5. Or you get 0.00369. Okay, you can write different way. You can say, okay, 3.69 power of minus 3. That's only a different way, okay, to get the number using power of 10. Okay. Basically, this one, we don't have to go through, okay? You guys can read through it and you're able to understand how they do. If you get a 1.2 power times power of 3, multiply by 1.5 power of 4, the formula will be 1.2 times 1.5, okay? And the power you must be add them up. Power of 3 plus power of 5, power of 4. You get 1.8 times 10 power 7. Okay? And for the division, if you get a number here, divide to 3 times 10 power minus 2, what you can do? 4.5 divided by 3. Okay? The power will be power of 2 minus 2 power of minus 2. So that's why you can get 1.5 times 10 power of 2 minus 2. will be -4. Okay. So any question about that thing? That's a very, very basic. And if you not get along, try to go through that. Okay. And also, you get an example here. You can try to see you get the answer here or not. And when you get a time, you can try number A and number B. Okay? If you cannot get the answer, then you can give it to me a question later. Okay? Additional and subtraction using power of 10. You want to add two number to that number. Okay? First thing, make sure when you're adding, the power will be the same. Okay? Or you see that 5 times power of 3. Okay, equal 50 power of 2. We already know to do what the 10 power. Okay, so that's why they can say 3 power 3.25 times 10 to the power of 2, adding 50 times 10 power of 2. Okay, so basically you adding the number here and the power will be power of 2. Okay, that's how to handle for adding or subtracting number with the power of 10. Power, raising a number to a power either form multiplication or division. Okay, if the exponential is negative, for example, if you get 2 times 10 power of 3 power of 2, okay, then you can get look like 2 times 10 power of 3 times 2 power of 10 power of 3. You take number 2 times number 2, you get 4, okay, and the power you add them up, you get power of 6, okay, and this will be, they telling you how to do it. You can read that, okay, and you can try with the example. I already given the solution, okay, that you need to get through it. Next one, power of 10. 10 power of 12, they call a tera. Okay, symbol will be capital T. 10 power of 9, giga, capital G. Power of 6, mega, capital M. Then kilo, K, milli, M, micro, M, micro, pico, P. Like when you go to buy the computer, they can ask you how many memory you want. You can say, okay, I want 8 gigabyte. That means you take time 8 times 10 power of 9. Okay, buy me 8 bit. That only telling you. From now on, if they're talking about tera, you know, the symbol will be T and the power will be 10 power of 12, and so on. Okay. Okay, the next one. You get your car battery. Okay. Get the battery here, you get a positive, you get a negative. Okay. When you turn on your light, see what happened. First thing, you can see you can get the current flow here. Okay. The current flowing from positive. However, how come we get the current? Okay. You get the current, the thing is, the electron will be moving. Okay, when you apply power, the electron will be moving from negative, okay, electron current going, electron moving from negative to the positive. That's how you get current. However, we're talking about current really go to the positive to the negative. Okay, that's what the conventional current. That's what they use it. Even both current will be the same thing. Electron moving create the current. And we're talking about electronic, we're talking about conventional current will be flowing from positive to the negative. So now you turn on the light, okay? Then you can see your light. Turn it on. If you touch it, you feel really a little hot. See what happened? What is it here? That's just a resistance. Okay? When the current goes to the resistance, that means they converting into the heat. So that's why you touch here, you feel little hot. Okay? That is how the current flowing. Now, if you say that not on, what happened? When you turn on the light, but the light is not on, what happened?
Dead battery, or the resistor is blown.
Yeah, this is basically the resistor inside. They're broken. Okay? When they're broken, current cannot flow through it. So that's why they're not on. So basically, you can see for the electronics, the current, okay, converting, okay, from electrical into the heat, okay? That's how they work. Now, they're talking about resistance. Resistance is the opposition to electric flow. A component manufactured to have a resistance equal a resistor. Conductor like copper have a little resistance. Okay, this is a symbol for the resistor. In the schematic, they're using this symbol here. You see that one. You know this is a resistor. The letter symbol R. That means R resistor. The unit of resistance is the ohm. Also, they can using this symbol. That is the ohm. Okay? So when you see the symbol, you know this is the resistor. And the unit of resistance, they will be in ohm. That we don't care. That's more physical of the resistor. Okay, we not deal with that. And that one showing you, we get a different type of the resistor. Small one, a little bigger, bigger and bigger. Actually, size of carbon resistor that will be telling you this can handle 2 watt, 1 watt, uh, 1/4 watt and 1/8 watt. That only telling you. If you're using a small here, you connect a current higher, they will be burned out. Okay? So when you're looking into the resistor, okay, then you're able to recognize also how many ohm or kilo ohm, how many watt. Also, in industry, they're using power resistor. That means different type. Okay, if you're looking into that resistor, they call power resistor. And also, this is another one. They show an integrated resistor network. What that means? They get 1, 2, 3, 4, 5, 6, 7, 8. That means both sides they get 60. Okay. So basically they can get 1 resistor, 2 resistor, 3, 4, 5, 6, 7, 8. Put it everything inside here. Why they need that one? The reason is they really want to save the room in the circuit board. So they don't want to put 8 resistor that take up more room. They can put everything inside one part here, and they can save a lot of room. That is the reason. Okay? That will be external view variable resistor. That means for this resistor, they get a button here, you can turn around. That means you can change the value of the resistor. I'm giving you example. You get a 1 kilo ohm resistor. That means you can get any resistor from 1 to 1 kilo ohm by adjust this port. That's what they call variable. Okay? Now, this is the color code. This is a resistor. They call it general purpose resistor 4 band. 1 band, 2 band, 3 band, 4 band. First band they call a first significant digit. Second be second significant digit. Next one will be multiplier. And the last one tolerant. That's a general. Precision resistor, they get 5 band. 1, 2, 3, 4, 5. Okay. Precision resistor cost more than 4 band. Okay. The thing is more accurate. This is the table given to you. First band. Okay. First digit. Okay. If color brown, that means the number 1. Red number 2, and so on. Second band. Second digit. Okay. That means if you say red, you can get 2 and 2. Okay. And multiplier third band. That means you multiply whatever value by that number. 10 power of 0 equal 1. 10 power of 1 equal 10. 10 power of 2 equal 100 and so on. Okay, now, why they need the color register code? That means on the register, okay, let's see. In here, you can see they get the color. By looking into the color, you can tell the value of the register. That's why you need the color code. However, technicians, we don't care much about reading color code. For example, if you interview for the job they given you register, they will be asking you, can you tell me what the value of the register? And if you say looking into the code in the color in here, and you're using the table here, calculate, you can get the value. However, I don't think you can memorize that. You can see, you can memorize a green number 5 or blue number 6. No way. Normally, if you get a similar, then you have to. But for the technician, if you get interview, I given you register. I asking you, can you tell me the value? How can we answer?
Multimeter?
Who telling me? You know, I've been an engineer working for too many years. I interview a lot of technicians. If I asking you, okay, telling me what value of the register, how can we answer?
Use the color code.
No. If you're using the color code to see, then you can come up with the number, right?
Mhm.
But the thing I believe that I cannot memorize this table, then we cannot talking about using the color code to calculate it. No way. Even they asking me, I give up, right? I couldn't remember the table. So the answer will be you using the meter, DMM. DMM can measure the voltage, measure the current, measure the resistor, measure everything. Then the answer will be, if you give it to me the meter, DMM, I can tell you the value. Correct? That is the right answer for the technician. I given you example. Okay, you can using the DMM to measure resistance from A to B, and you tell the value. If you can using the color code to telling them the value. However, what happened is inside register they open here. Then that is not a good register. However, the meter will be telling you exactly the value. Okay, so that is the answer for technician. The good answer for this question is you can say, okay, you want to know the value by color code or using the meter. If they say color code, you can say, I know how to calculate it. However, I cannot memorize the color code table. That's it, nothing else. Okay, this is the precision. That's a little different. Only thing is, the difference will be accurate, much better. Okay, if you're using this resistor, 1 kilo ohm, they can plus or minus 0.1%. Okay, that means more accurate than the other one. The other one you can see accurate will be 5%, 10%, 20%. That will be cheaper. If you buy this 4-band resistor, maybe cost about 5 cents, one resistor. But for precision resistor, you pay for 25 cents. That's only thing, the difference. Okay, let's see. A resistor manufacturer produce carbon composition resistor 100 mega ohm with a tolerance plus or 5%. What will be the color code on the resistor? Okay. A, you get a brown, green, yellow, silver. Okay. Then you have to tell them, what the value. You're using the 4-band. Okay. And on this number B, they will be 5-band. Okay. And you have to see the 5-band precision color. Okay. You have to try, but we not emphasize on in order to get the value by color code, we don't care. We really care. If I want the value of resistor, you have to using the meter to get it. Next one, conductance. Conductance Z is defined as measure of material ability to allow the flow of charge and aside the SI unit, the Siemens. G will be conductance, opposite to the resistor. Okay, that means resistor will be try to prevent the current flowing. Conductance opposite, that means good conductance will be good path for the current flowing. Okay, an example, they say determine conductance of the following resistor 5 ohm. You using 1/5. You get, however, unit will be S Siemens. Okay. Now, next we're talking about Ohm law. The relation between applied voltage E and the current I and the resistor R. The first formula will be E voltage equal I times R. In this formula, E will be applied voltage in volt. I will be the current in ampere. R will be resistance in ohm. That's what they call Ohm law. Okay? From this formula, you can calculate I easy. I equal E divided to R. Or you can calculate resistor equal E divided to R. Okay? Now, the lamp, okay, draw you get 25 milliamp. When connect to a 6-volt battery, what is resistance? You using this Ohm law. You calculate R. R equal E divided I. That's given to you 240 ohm. That's a very simple. Not too much formula. E of V equal I times R. That's the first thing, that's the Ohm law. From that formula, you can calculate I or you can calculate R. That's the first thing. Second thing, what unit of the E will be volt? I will be in ampere. R will be in ohm. Okay? If you get any question, just stop me, okay? I try to explain to you. This is very, very basic for electronics. Combine Ohm law and power formula. You know that the Ohm law V equal I times R. I equal V divided R. And now they want to calculate the power. In this is the power P equal V times I. And the power will be in watt. You can see the light, okay? 50 watt, 100 watt, or milliwatt, okay? That's the power. And also, they can give you another formula. P equal I square times R. Or P equal V square over R. Either way, you can calculate the power. P equal V times I, or I square times R, or V square divided to R. And the power unit will be watt, milliwatt, kilowatt, okay, whatever. Unit of R will be ohm, kilo ohm, mega ohm. Unit of I will be ampere, milliampere, microampere, kiloampere, whatever. That's a very, very general, okay? Make sure you know which formula you want to use and what the unit is supposed to be. Okay, now they're talking about series circuit. You get two different types. One will be a series circuitry. Next one will be parallel circuit. First thing, current is the same everywhere in the circuit. That's what series. The total resistance is equal to the sum of the individual resistance. The total voltage is equal the sum of the IR voltage drop across the individual resistance, and the total power is equal to the sum of power dissipated by each resistance. That summarize everything for the series circuitry. Now, you will see this problem here. This is the series circuitry. You get the first one, R1 2 ohm, R2 6 ohm, R3 4 ohm. Okay. When you're looking into the circuitry, how do we recognize, okay, the series? In here, they already see current is the same. That will be telling you the current flow here. They flow through R1, they flow through R2, and they flow through R3. That means only one current. Okay? And now I can tell you this side positive, this side negative. Okay? When the current flow through R1, they have to be positive, and they have to be negative. Current coming in positive, leaving negative. That will be telling you the voltage at this point will be higher than the voltage at this point, B. Why? The thing is, go to R1, okay, they're converting electrical to the heat, so that's why the voltage will be dropped. Also, when I go to R2, this side positive, this side negative, the thing, same thing. When current coming in, positive, leaving, negative. So if I'm looking into this circuitry, I say this is a series circuit. The thing is, on off the resistor connect into this circuitry, get the same current I. Or sometimes they can say, for the series circuitry, that means the resistor connect 1 to 1. Okay, that means the first one connection and will connect to the next one, keep going. Okay, and also they explain to you here, current is the same. Voltage across each resistor is different. Power dissipated each resistance is different. Now, if you want to combine R1, R2, R3 to only one resistor, that's what they call a total resistor. Add them up no matter how many resistors you get. So if you get a total resistor here, 2 ohm, 6 plus 6 ohm, 8 ohm, but 4 ohm, you get 12 ohm. Okay. Voltage across R1, VR1. Okay. That means the voltage across here. VR1. You're using the Ohm law. V equal I times R. So that's why you can see VR1 equal I times R1. Okay. Also, you have to understand one thing. VR1. If you're looking into the schematic, that means the voltage from A to B. So you have to say same thing, VA, B. Now, VAB, that also means VA minus VB. That will be very, very basic for definition. VR1, that means from voltage A to B. They say VAB. And that VAB, that means VA minus VB. Same thing. You can see VR2 from B to C. That means VBC. Same thing. VB minus VC, and so on. Okay? And for this circuitry, they want the total. That's easy, right? You add them up. Total current. That means E divided to R total.
The 12.
Yeah, it's easy for the guy calculation. We don't want to have to go through. Total current. You take E divide to R total. That's why you get I total. And VR1 I times R1. VR2 I times R2. VR3 I times R3. Power R1. Power, the formula will be P R1 I square times R1. Power up 2, I square times R2, and so on. Okay? Only thing is make sure, okay, you get the time, you go to the example, okay? You know how to do the calculation. Okay, the next one. Voltage divider rules. Okay. Apply to the serial circuit only. Okay. That means now you get this circuitry, series connection. You get R1, R2, R3, R4. If you want to calculate the current, easy, right? You have to calculate the total resistance. R1 plus R2 plus R3 plus R4. That means you get a total resistance. And now you want to current. You get 20 volt divide R total. That means you get the current. Okay? So that's the current flow here. Okay? So if you want to calculate the current, then you take total voltage divide to total resistance. Okay? Now, if I want to calculate the VC, right here. When we want to calculate the VC, that means from C to the round. That is VC. How can we do? From the C to the round, how many resistors? 2. 150 and 200. So, if you're doing a calculation, you can calculate the current I, then you multiply by 150, you get R3. And you multiply by 200, you get voltage R4. You add them up. That means they want the voltage from VC. Okay. So now, in order to calculate, you have to calculate the current. You have to calculate the total resistance before you can calculate the VC. And now what they want to do, okay, they want to using what they call a voltage divider law. Okay, let's see. They want, let's see, for the circuit cell, use the voltage divider. Calculate VB. Okay, they want calculate right here. VB. That means this one. Okay. So normally, if you want to do calculation normal, you have to calculate the current I. You have to calculate the total resistance. And from the B, VB, okay, that means from B to round, you can get a 1 voltage here, adding 1 voltage here, adding 1 voltage here. That means VB. So they want to using the voltage divider. I show you. So you can using this formula. VB. Okay. Let's see. VB equal E time. Okay. Let's see. R2, R3, R4. Everything divide. Total resistance. R1, R2, R3, R4. Okay. Instead, you have to calculate the total resistance, calculate the total current. Then you can calculate the VB to the round. Then you can using this formula. You can see E divide R1 plus R2 plus R3 plus R4. That is the current. And time R2, R3, R4. That means from here, go to the round. Okay. So finally, I want you to give the formula to calculate at this point here. Using the voltage divider. Okay. That means VA. First thing, you using total. Time. Time what? Who knows? Time which one?
R4?
R4.
Perfect. R4 divide. R1. R2. R3. Okay? That's how we're using voltage divider. If you're not using the voltage divider, then what you have to do is you have to calculate the total resistance, calculate the current, and from point A to round, you multiply current to R4. Okay, quickly go to that one. Parallel circuit. Voltage is the same across each resistor. Total current is equal to the sum of the individual branch current. Equivalent resistance are equivalent is less than the smallest branch resistance. Total power equal to the sum of the power dissipated by each resistance. Okay? When you see this circuitry, you know this is a parallel. Okay? You can see this is the power here. Okay? Connect to R1, R2, Rn anymore. We don't care. So the current going from total power, current I, when they go into this point, okay, you can see one current go here. So we call I1. Go to here, you get I2 or IN, depending on the resistor. Okay, so that will be telling you one thing. In the parallel, all of the voltage across each resistor will be the same. You see that? However, only difference will be current. Depend on the value of R1, R2, R3. Okay? The resistor get a bigger, the current will be less. Okay? What they say here, all resistors connected in parallel will have the same voltage. E equal VR1, R2, R3. The current through each resistor, that we call a branch current, in parallel are different. Okay? And the total current will be I total I1 plus I2 plus IN. R total. Okay? Total resistance or equivalent resistance calculated by this formula. R total equal 1 divide 1 over R1, 1 over R2, and so on. If you try to combine this circuitry to the circuit only one resistor, equivalent, you have to use this formula. However, if you get only two resistors, you can use this formula. R total equal R time R1 time R2 divide R1 plus R2. Okay. Now, if you get R1, R2, R3, 18 ohm, 9 ohm, 6 ohm, they're looking for total resistor. Okay. You get 3 resistors, you have to using this formula. Okay. And now another one. Okay. R1, R2, R3, R4. However, they want to calculate the total resistor looking into here and here. So what you have to do, okay, you have combine R1, R2. Okay. So you can get R1, R2. You're using the formula only two parallel. That means R1, okay, time R2 divide R1 plus R2. And now you combine R3, R4. Will be equal to R3 time R4 divide R3 plus R4. Okay. Finally, R total equal R1 joule parallel R3, 4. Okay. And you can calculate R1 joule times R3, 4 divide R1 joule plus R3, 4. That's how we're doing calculation. Okay, this one, save for your guy, okay? You have to get the time to working on that. Okay, and also this is an example. And also we already get the solution for you. Okay, you have to try. Okay, we don't want to waste the time on that. Now, we'll be talking about meter. You know this is a DMM. Okay, you can measure the current, you can measure the resistance, voltage. So if you want to measure the voltage, you connect the positive here and the negative to the ground. Like you want to connect to a car battery to see how many volt. You connect positive to positive, negative to ground. They telling you what the voltage. Okay. Only the difference will be if you want to measure the current, this is to measure the current. Okay. What you have to do, the positive you connect into, okay, positive here. However, you have to break the circuit. Okay. You can break the circuitry. break it out. So you connect one side here, another side here. Let the current flow through the meter to get the value. So that's why in really at work you never have to measure the current. Why? When you measure the current, you have to break the circuitry. Your job will be something wrong with the circuit board they want you to fix. And now you break that in the circuit board, that's not allowed. Okay? Normally, engineer, we're not asking you to measure the frequency. If we want the frequency, we're telling you measure the voltage. After you get the voltage, you divide to the resistor, you get the current. Okay? And now, remember, if you want to measure the current, okay, first thing I tell you want to make the current flow here. You have to break that guy here and connect the meter. Okay, let the current go through the meter and return to the route. That's what you have to know when you're working with the left level. If you don't know, you can cook the meter. That means the field will be broken inside. Okay. That's what the meter, you get the time. Okay. You can looking into that. Okay. Measure AC DC or measure capacitance diode of frequency. Depend how much you pay for the meter. This meter cost more, $400. And most meter we bought later cost around 200. Okay. So now, just telling you a little more. Okay. You have to looking into that. What I want quickly get through it. The thing is what I want to telling you. I will introduce to you. Okay. About the left volt. So that means on Monday, okay, when you come into the class, if you understand, then you can start doing the level. Okay, now let's see. Okay, now I will show you what's going on with the level. Okay, now you see it? This is the level system. Okay. Now this is the circuit board. You will be testing. Okay. If you're looking into the circuit board, this is the battery, this is the switch, this is the Ohm law. Okay. If they telling you testing Ohm law, that means you're working on this circuit, or series circuit, or parallel circuit, so on. Okay, first thing I can telling you one thing. In here, they get you power right here. This is the negative power. This is the positive power. Okay, they can go from 0 to 15 volt. Okay, now this is circuit board. You want to do DC fundamental. So we have to plug it in. Remember, you cannot plug it in. You cannot remove the circuit out. Technician, electronic, instructor lab will be doing for you. Okay? In the past, they did it. They got the problem for the circuit board or for the connector here. Okay? Then we have to fix it, take a lot of time. So on off the remove the board or plug the board in. Okay? The instructor lab will be do for you. Okay? So looking into the board, okay, you can see the first thing you will be doing will be Ohm law. Okay. Like this, first one you don't have to do, depending on the requirement. When you come up to the class, you can see they're asking you, first thing you do Ohm law, next one you do series, parallel, or so on. Depend on what they want. Okay, any question about that one? Okay, if it's not, okay. Now, next one.
I have a question.
Yeah,
So the negative current goes to the right and the positive current goes to the left, or how does that work?
that
Does it
means
all
the
go in the
power
same direction?
supply. Power supply for this circuit. Okay? That means if you go to 10 volt, you have to adjust this one. If you want a minus 10 volt for your circuitry, you have to adjust this guy. Okay?
Okay.
This is the power supply for the circuitry.
So when you add 5 volts on each side, what do you get? 10 volts? Or what?
On the right side here is a 10, maximum 15. On the left side will be negative.
Oh, okay, okay. So if you go positive 10 volts and then you
Yeah,
go
if they
mi-
asking you to adjust 10 volt, then you have to using this port here. If they say I want minus 10, then you have to using that one.
okay.
Okay, that is the same. Okay, you see that? When you get into the Monday, you want to working on the left phone. You need to get into the left phone. Okay, instructor will be helping you how to get it in. Okay, after you get it in, they show you, I want to run the law. You see that? Law.
Yeah.
Then you click on law. Okay. After you click on law, okay. Now try to see. Law. Okay. When you click it in law, they show you law here. Okay. And you click next, they can go to next here. So in here they say object fundamental. Okay. Equipment required. Only thing is, I want you to click on exercise 1. Okay. This is a theory, a lot of theory. If you want to be a real understand DC, AC circuitry, take 2 years. Okay. There's too much detail. We only spend on exercise. So you have to click on exercise 1. After that, you exercise 2 and 3 and unit test. Okay. So in here, you see that they're talking about object everything. We don't want that. If you want later, you get more time, you can go through it. However, we don't have a time to get through everything here. That takes too much. And now, for example, on that one here, they can give it you question, multiple choice A or B or C. We don't care.
Oh, okay.
You can pick A or you can pick B or C. Doesn't matter until they're telling you that is the right answer. Okay? Multiple choice doesn't matter. You click until they say, okay, correct, that be fine. Otherwise, you spend the time to get through it. I don't think we don't have enough time to do it. When you click it, they say correct, and you reading, you thinking. Okay, doesn't matter. That's law. We just talk to you. Equal I comma I equal A divide. So far.
Oh. R equals EI.
Yeah. You keep going. Okay. And now they're talking about register using the color. Okay. I just keep going. Okay. If you don't know right, you see that? You click it and they give it to you. Okay. Now, law circuit. We have to make sure, click on procedure. Okay? We don't care about discussion, anything else. You think a lot of theory. When you get the time, you can go back to that to read it. That doesn't matter to me. You see that? The answer here. But not up to the point we want to do, right here. Now, if you're reading that, you see what they said. Locate the Ohm law. This is the Ohm law here. This circuitry here. Okay. Based on resistivity, color code, and the band on R1. What is the resistance value? That means you're looking on the color in R1 and your calculator telling you what value. Okay. This is the answer. If you're doing it right. Okay. Now, you're looking into your circuitry here. That's what I try to explain to you. They can say R1 here and R2, the asking value R2. Okay. They can say you can using meter to measure or whatever. Now, right now, they want our value R1. Then later on R2, so on. I want to talking about circuitry. When you see the dot here, what that mean?
We don't care. Keeps going.
It's
Keep
the
going.
positive side? Or
No.
What?
Where you see dot here, that will be telling you this side not connect to that one. You understand that?
So we need to put a cable between the two dots.
That we need somehow to make a connection. All same thing here, correct?
Yeah.
So that's where the switch goes, right? No?
They not connected. You have to make a connection. We're telling you.
So that's a good point to put your amp meter there if you want to measure.
Now I'm talking about connection first. Okay. They not connect yet, right? That means they still doing something without a connection. Now, what they want, using the meter, connect our what? Or using the meter, connect our two. Okay? You see that? I believe you can do it. No problem.
So that gives you the value?
What?
Does that give you the meter gives you the value, right?
I don't know. The value. If you're doing it right, for example, okay, what they telling you measure the value. Okay? If you enter the value correct, they say correct. Otherwise, incorrect. Then you have to do until correct before you can move on. Okay, now, this thing you have to know. They want measure resistor from this point to this point. So that's why you have to connect there. They call a two port connector. Okay, inside the box, in the lab, you take that, connect that one. Make sure they connect R1 to R2. Then that you can measure. You get that?
Yes.
The thing is I understand, and Monday you can do it easy. Okay? For example, this measure they get 1500 ohm. Okay, now they want to measure the voltage power here. Okay, they want 10 volt. Okay, if it's not 10 volt, what can you do?
Change the power supply.
When they telling you connect positive, negative to across the power supply, and they want the display is 10 volt, but they're not 10 volt, what can you do?
Lower the voltage or add it.
Increase the voltage with the knobs.
Either increase or decrease, right?
Yeah.
However, where? How?
The knobs at the top.
Perfect. You go to the top on the right?
Sure.
Adjust either higher or lower until the display 10 volt. Easy. Okay. Now, they want to measure the current. Okay. So basically the more positive of the current connect here. Okay. And the negative connect the other side. However, make sure this still have to get the connection. If this one is not connection, open circuitry, current cannot flow. So basically the current will be flowing from here, go through the meter and return into this side, go to the route. Okay? And it's just a calculation, whatever, we don't care. Okay? Okay, now, when you run up to the point they say GM19 activate. If you're looking into the one you already did it, you measure the current, you enter OK, correct. Later on, they say CM19 activate. Do the same. What that mean? How much the people understand what they want?
The
It's just
question,
a measure doing the same like we already did it. However, now they say CM activate. I believe you cannot understand. The reason is they want to make sure you know how to do it. However, CM19 activate, that means inside the circuitry they change the value. And the measure the current now will be different. You see what that means? CM, either 1, 2, 3, up whatever number. That means they're using their software to change any value inside that circuitry to guarantee you know how to do it. You see that tool is very, very, very good for training. You see that? Until you know how to do what to do. If you already did that one, you know what's going on. Then when you go into the CM, no problem.
what is CM in this case?
Then the module somehow.
Module. Okay,
What mean? They change something. Okay. Correct CM add add a 2200 ohm to the circuitry. That means they modify inside the box. They adding the resistor in here. So the current now different. If you know how to do, you get right answer.
So you are saying that this board is changing programmatically, so there's some
They
logic.
changing inside the box.
Mhm.
Okay? You see, they changing inside the box, not on the board. To make the circuitry different resistor. So different current. Normally, okay, we almost are going quickly going down. Okay? That means too many things. You have to do measure power, measure current, measure the voltage. Okay? Whatever here. Okay? Finally, that one. Do you want to take the unit test now? Yes. You answer the question. Okay? They given you the question, you answer it. They telling you how many percent you get. Okay? Only thing I want to make sure, okay? You have to do Ohm law, series, parallel power, whatever here. They list on the left. If you get it through it, you get it done. Then you go to the another board. That will be electronic, about diode or whatever. Okay? So when you do it done, they say complete. Okay? If you're doing a halfway of the Ohm law, next day you log in, they take you right away. At the time you left, keep moving. Okay? And everything will be recorded in the server system. We're looking into that, we know which app, what you learn. Okay, okay. That's a very, very good, okay, for your guy. I believe on Monday when you come, I will also be there. And the lab instructor, okay, will help you to start. Okay. Now I given you the way we supposed to do. Any question up to that point?
So we do the top areas of Ohm law series circuits first, and then we work our way down to the last one, correct?
Right.
Okay.
So someone know how to do it, maybe just a week you can get through it. No problem. 3 days. So I don't know. That's what I'm telling you. Nowhere they can get this lab like we do. Why? Cost too much. Okay? So that's why they don't want it. They can open a lot of, continuing education everywhere, every different city. However, they can open just ESL or few things, nothing can help, but not electronic technician. The thing is, it got too much money to open the electronic technician club. So you can see only San Diego, we are lucky. and I keep going, keep running the program up to the point I cannot do it. So forget it. Okay, any question, anything?
How many people can do this lab at the same time in your lab?
Right. You going to do something you do about 2 hour and a half, and the other people coming in later, that means from, I believe, 6 to 8:30, then you have to go.
Yeah, but like at the same time, you got like how many? 30 seats or how many? Just an idea.
Now, the thing depends on how many ball we get. I believe I get only 12 ball.
Ah, okay. 12 board of the same kind, right?
Right.
Okay, got it.
In the lab, we get 20 sit-up.
Mhm.
However, the circuitry for the electronic, we get a different. This one we get more, that means 12 or 13 or 14. That means 13 people can do at the same time. When I coming
Understood.
on Monday, I could tell the lab instructor get on of the DC circuitry connect into the setup. And when you coming, and I telling you, you go to number 1, next go to number 2, 3, 4, 5. Keep going. Okay? If you know how to do what to do, very exciting to do it. If you get a problem, just go ahead and ask. Okay?
Professor, say we get 2 of these little exercises on Monday, then come Tuesday, can we go to any computer to continue?
If you're already done, right? If you're not done on DC, you don't have to be sit on that computer again. You can sit in a different computer.
Okay,
The thing is software, if you left over today, next day you get in. They start from whatever you left over. Don't worry. Everything will be stored in the server.
okay,
Only thing you enter your name or password, whatever, they know who. So that's why this software will very, very good for training.
Hey, Mr. Pham,
Yes, sir.
just in case, tell them to get a memory stick.
Memory stick. That means
are you saying because we need to save some files or something?
No, use a memory stick so if something happened, you'll have to work on your memory stick.
Oh, okay,
Like a backup, like a backup. A USB.
yeah, that depends, I don't care. But however, that will be recording in server. Only we can see it. Okay, so any question, anything? Before we leaving. Okay, any question, anything? So your guy will be ready for Monday.
yeah, one question. So will you have the Tech 2 students in the same room at the same time with us on
But-
Monday?
They're not doing on the lab vote.
Okay,
They're doing in digital area. You understand? Tech 1 will be using electronic based on electronic. Tech 2 will be based on digital fundamental. You see, you can see they build the circuitry, they develop the test to test the circuitry. If they're not working, how can they find out what's wrong with the circuit to fix it? That means troubleshooting. So that's quite different. Okay? They're not using left vote.
Okay.
You guys get priority. If this week you done for the DC, and the next week you will be working on another board. Okay? More circuit board you get through it, that means you're okay. That's what required. Okay? So, if,
Mr. Fung,
yeah,
do you have handouts for the other circuit boards?
hand out for the circuit board.
Yeah, for the other, for like the, oh, it's all here, never mind.
You see the circuitry I showed you?
Yeah,
You think that will be hand out? No, we don't have a hand out. You
Mr.
can-
Pham, you need to tell him how to download that stuff that you had. He needs to know how to download it.
No, I don't think so. I don't think so. You cannot download it.
No. The thing that you had on the board. Remember how you always say download the stuff that you're going to talk about
Oh,
at the beginning? That's what he needs. Then he can
No, okay,
look at it.
okay, I have that.
I'm telling you.
So you have all this stuff from previous semester here. So I guess we are doing the same thing, right? Like
Oh.
previous.
Different.
Different.
Different. The thing is, every semester I'm looking into that. I said, which way we can do better for you guys. Normally, for this meeting will be already recorded. I will be upload into the web later on. If you want to see, look it back for this handout, for this meeting, you can click on, they will be show you on the YouTube. Okay? All of the meeting will be recorded and will be shown on YouTube. Okay? You can watch it again. Okay? Any more question? Anything? Otherwise, I wish you guys get a good weekend. Okay? And we will see you on Monday.
Thank you, instructor. Thank you.
Bye bye.
Thank you.
Thank you, Mr. Pham.
Yeah.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Good
Thank
night.
you so
You're
much.
welcome. Bye bye.
Bye bye.